Well, hello. Welcome to Regents Review Session 2. This is going to be on rigid motions and similarity. I recommend that you have some scrap graph paper to put in your vocab notebook as well. This should be a fairly quick video, but it does have several important ideas, so please make sure that you're pausing when you need to. A rigid motion of a plane is also called an isometry, although we don't see that word as much anymore. It's a motion that preserves distance, so a rigid motion does not change size or shape. There's 4 rigid motions, 3 of which we do quite a bit of, and then the 4th one is mentioned randomly. The first one is a reflection, the second one is a translation, the third one is a rotation, and the 4th one is called a glide reflection. Please remember that key words for these rigid motions for a reflection, remember, is a flip, and a translation, we remember keywords to kind of slide, because the FL in reflection and the SL in translation help us. Rotation, most of us know, is a turn. A glide reflection is a slide and then a flip. And it kind of tells us that in here. We don't do quite a bit. We don't do a lot with glide reflections, but it is just what it sounds like, a slide and then a flip over. I would recommend that you graph what a reflection looks like. This happens to be a reflection in the x-axis, where we take this original or pre-image and we flip it over the x-axis to get the image. Remember, in order to do a reflection, you take the point, we'll start with W, you count to the reflection line, 1, 2, 3, 4, and you repeat, 1, 2, 3, 4, and that's where you get your image point. A reflection in any axis, X or Y, is fairly easy. Also, a reflection in, say, the line Y equals 2. The line Y equals 2 would be here, so you would count to that reflection line, 1, 2, and you would repeat, 1, 2. There is a reflection that's a little bit more challenging. This is a reflection of the line Y equals X. The line Y equals X actually comes up. Let's see if I can draw some dots in here. The line of reflection, that it actually comes up and it kind of makes this line where 1, 1, 2, 2, 3, 3, it's kind of this line right here. Now, what we have to remember is that in this particular case, it's not as easy to just count to get to those particular points. So I would recommend that you know this rule right here. A reflection in the line Y equals X, let me just ignore this for a minute, it would be, to know this rule is going to be a little bit easier, and the rule is just flip the order, such as it says right there. So if you start out with a point XY, you're just going to flip it YX. So this point in the pre-image of L is 0, 2. So once you reflect it in the line Y equals X, it becomes 2, 0, which is over here. Those are the 2 reflection examples. Continuing on, we have a translation. A translation is a slide. So in this case, the black triangle is your pre-image. And so we want to translate this 1 left and 2 units up. And that becomes your image point. Remember, in symbol form, a capital T is a translation. This tells you what direction to move. It's always XY, just like graphing. So you're going to move -1 on the X and 2 on the Y. Same thing for this symbolic form. These are vectors. That's a vector right there. And this just means, again, X is -1 and Y is 2. Please don't make that more challenging. It goes right in order what we have seen before. X, Y. Same thing here. X, Y. Please, please, please don't make it more challenging and don't switch them around. We're used to XY, we leave it XY. The last type of rigid motion that we've done quite a bit on is the rotations. Now, when you do a rotation, 9 times out of 10, it's counterclockwise. So the symbolic form is a capital R, tells you the degree. In this particular case, if we want to take this image, this pre-image, and we want to rotate it 90 degrees counterclockwise, you literally take your paper, see if I can do this neatly, and you rotate it 90 degrees counterclockwise. This B value started out as the point -5, 1, and it became -1, -5. So -4, -1, -4. So once you get the new point, then turn your paper back to its original position, or your graph back to its original position, and then you graph the point -1, -4. So you literally turn your paper and then turn it back. Dilations are the last type of transformation that we did, but dilations are not rigid motions. Dilations are changing the size. So in this particular case, the pre-image was littler and the image was larger. This would be a scale factor of 2. Anytime you have a whole number as a scale factor, then the shape starts out small and gets larger. A scale factor of 1/2 or anything less than 1 means that the shape starts out and gets smaller. So, and this should actually say pre-image and this should say image. That's a typo right there. So make sure that you don't write image. This is the pre-image. This is the image after a scale factor of 1/2. The scale factor is the image size over the pre-image size. The other thing that you want to remember, in dilations, angles do not change. So in dilations, angle measures remain the same. So you want to make sure that you notice that. In dilations, angle measures remain the same. Then we're going to talk about similarity. This is the final topic for today. Similarity means that you have similar triangles in the fact that they look exactly the same, except one is larger than the other. The angle measures will remain the same. So angle A is the same as angle X. If angle A is 70, then angle X is 70. These are corresponding angles. If B is 90, then Y is 90. If C is, what did I say this was? So this is 90, so this would left be 30, 70, and 90 is 160. And this would be 20, so 20 and 20. All the angle measures stay the same. Be consistent when you are labeling your corresponding sides to show that they're in proportion. BA corresponds with XY, so 16 over 32. They are all going to have the same scale factor. 22 over 44, 25 over 50. They all have the same proportion, the same ratio. These simplify to 1/2. If we were going from the larger shape to the smaller shape, then you would start out with 32 and on the bottom would be 16. It still all has the same ratio of 2:1, 2:1, 2:1. Or if you had this as your pre-image, 1:2, 1:2, 1:2. Similar figures have equal angles and scale factors are proportional. Okay, similar figures have equal angles and the scale factors are proportional. So please make sure that you recognize that. The last thing that we're going to talk about today are when you have 3 right triangles in one picture. This is what we called, and this has been on the board for a long time, or it was for a long time, relatively positioned triangles will help you in matching parts. So in this particular case, we have a small triangle, we have a medium-sized triangle, and we have a large-sized triangle, and all of them are right angles. So if you're going to write, this was Mama Bear, Papa Bear, Baby Bear, this was the small, medium, large. When you are focusing on the small triangle, we want to draw this in such a way that we can make the other ones the same position. So in this case, the C is the right angle, the A is the height, the CA creates the height, and the short side is on the bottom. The short side is always the piece of this big, long side of the picture. In order to take your medium triangle, which is right here, and relatively proportional or relatively position it, we have to take this and we basically rotate it so that this comes up. We rotate it clockwise so that that D comes up, and therefore the C is still the right angle. The D becomes the height. Also, the short side of the medium triangle is always the one that comes up through the shape kind of in the middle. And then your large triangle, the right angle is D. Again, in this case, we want to rotate, the right angle is A. In this case, we want to rotate this upwards, but we're also going to flip it to relatively position it. The A is the right angle, and then the short side of the large triangle is actually the hypotenuse of the small triangle, and the D is the height. You want to be able to draw those three triangles, so now you can create any proportion that you want. Height over height, hypotenuse over hypotenuse. You could do base over base, and height over height. You could set up as many proportions as you'd like as long as you match all the parts. Have a great day.